All right, so the Costerfield Project is about 120 k's north of Melbourne and is about 60 kilometres east of Bendigo. And it's basically nestled in around a lot of the previous deposits that we've been talking about this morning, Redcastle, Nagambie, Rushworth, those sort of areas. So it's really in the thick of it there. I guess what we're about is looking at antimony potential as well as gold. So I guess that's our primary company revenue source. And you can see our Mandalay itself, we've got 3 licences. We've got a primary mining licence with the main lines of load in the very significant and historic belt, which is Costerfield. And then we've got 2 surrounding exploration licences, which are really culminate to about over 100 square kilometres of ground. All right, so just a sort of a bit of an overview of geology. There's a Costerfield dome. I guess that's the real significant geological feature that we see in Costerfield. So the Costerfield dome is within the Melbourne suite of Silurian sediments, and is surrounded by, I guess to the east you've got the Heathcote volcanic suite, and then into the Bendigo terrain. But we're really concentrating the actual Costerfield deposit, or the area itself, is in a very monotonous, repetitive suite of Costerfield siltstones and intervening sandstones. So really for us it's about using what we've got there as far as our knowledge of the geology, as well as an increasing knowledge of the structural component of the field as well. So we'll just, I guess just a brief thing of that map there. So you can sort of see in the there's a pointer there. So we've got the, where's that word? Anyway, see the light purple. It's sort of like a semicircle. The light purple is the Costerfield siltstone, and that is sort of allowing us to see the Costerfield dome, and that's where our principal area of interest is. And it's looking at the axial plane, biaxial plane, but the axial plane you can see in black there, the black dotted line, and that is really our focus of looking at extending our resource and exploration successes. So, all right, so just looking at one, I guess in exploration, what we're doing is trying to utilise our very shallow transported cover. So we talked about various covers. Some of the previous guys here were talking about covers of up to sort of 60, 80 metres. We enjoy a very small transported quaternary cover of only sort of 3 to 5 metres. If it's 6, 7 metres, it's very, very deep for us. What we have started to do and what we're gearing up for is an intensive auger program. So it's going to be a shallow auger drilling program. We're going to really hit these red zones quite hard. And when I say hard, we're going to do 50 metre space lines, 10 metre space drilling on those lines. So really, what we're about is looking at fit for purpose exploration with a strip, well not strip, but a very small transported cover into the bedrock. So it's all about bedrock geochem. And after we do those grids, we'll get the information back, multi-element geochem of course, but primarily looking on anomalous antimony. That seems to be our best indicator, followed by arsenic, and of course gold's always there as well. And so we'll look at Conley plotting or plotting up those, and from those particular gridded anomaly maps, we'll then go in and do HQ diamond core. And the HQ, the large diameter diamond core, is for a good sample support, because we're looking at quite narrow ore loads. So just looking at a schematic long section. So that long section's roughly running right through the guts of the field. So it's just looking at sort of running north-south through that area there. And what our real philosophy behind the near mine exploration, so this is after we're auger drilling and gaining all the information we possibly can. This includes a lot of historic information on a lot of workings in the area as well. So you can see the actual Costerfield field, mineral field, encompasses large historic workings like the Costerfield main. We've got Bombay, Minerva, we've got Allison workings, and of course Augusta mine that started up as AGD in 2006, and then changed over to Mandalay in 2008. But you can see the philosophy behind this is the steeply. So this is the domal. This is again the domal theory. So we've got the looking north. You've got the dome rolling, and in both dimensions, of course. So we're looking at a very steep northerly plunge of ore shoots in the southern part of the dome, and that includes the Augusta deposit. And then going to the north, we look at a very steep southerly plunge of in the northern part of the Costerfield dome. So, and it's really incredible. You know, you think about you know, mining in this region has been here for 120 years, and some of these workings, you know, the old timers, they knew it, they were around it. Really, you know, you look at these old mines and you think, gee, could there be anything possibly left, you know, around these mines when you look at drilling under them? Well, you know, we're really quite excited to say, well, yeah, there is. And our first two targets that we're drilling under old workings, i.e. the Tate's mine, which is just nestled between the Allison and the Augusta, or sorry, Tate's mine, the Costerfield South mine, and also the Allison mines, drilled under both of those and coming up with very, very good economic mineralisation. So really quite excited about that. So this is just sort of this is in the last release we did to the Toronto Exchange, but this map's just a brief map just to show, it's probably not the best map, but it shows the red dots with the tails of the diamond, HQ diamond drill holes that we're drilling in exploration around our near mine areas. So Augusta is the big massive blue underground development, and you can see there's MBO01, MBO02 right through to the MBO09 on that map, and that sort of shows we've got a lot of success. So MBO08, for instance, got the 15 centimetres of 90 grams gold and 15% antimony, and a really good hit for us. And again, really good success with drilling underneath the Allison workings, both in MBO07 and AD002, and you can see the grades there. Very exciting. So it's one of those things where, you know, and of course, looking back in the schematic long section, we've still got the Brunswick, the Bombay, Minerva, Costerfield workings to really explore under. So we're quite excited about doing that. So just a bit of a cross section, and this goes across. This is from west to east. So you can see that historically all the production out of Augusta, which is our current mine that we're mining at the moment, has been coming from the E lode, and then more recently, more production has been coming from the W lode. And as we drill the Augusta deeps further with these holes from the west to the east, we're finding this is continuing nicely for us. Obviously, HQ and NQ wedges are quite expensive, and it might be that we start drilling this from underground. But anyway, just back on where these things sit. So that's the Augusta lodes. Then we've got the N lode position, which is running up through this sort of area, and it's quite amazing actually the structural work that Chris Davis and his team have been doing is isolating the fact that we've got a lot of a hell of a lot of data is captured in these diamond holes with respect to structures, bedding, and all those sort of things. So you sort of see these are bedding lines, and we're on the western limb of the Costerfield Dome here, so we're looking at western dipping bedding. But importantly, in these deposits, we seem to get this warping. We get this parasitic folding happening on the limbs, and you can see it in plan view as well. This is the Augusta area, and this is going north through to the Costerfield main mine, so that's sort of travelling north. You can see the what do you call it? I guess the parasitic folding development, both in plan view and section view. So, and it's really important to see this in respect to the structures or the loads. So you can see there's W load, almost sort of sitting in the saddle of one of these parasitic synclines on the western limb of the Costerfield Dome. And so we're really paying a lot of attention to how these bedding measurements sit and how they interact with the loads. And we're building up data. A lot of good mapping is being done by Mike Mong and in Chris Davis's group there, where we're looking at mapping these and bringing it all together with the drill hole information. So it's really quite exciting stuff. And for exploration, we're able to use these parameters when we're drilling for the end load, and when we're also starting to drill now in the Allison area. So that's over in this area here. So we're really looking at fairly close and proximal exploration zones, but incredibly just so under-drilled historically. So it's really good to be able to sort of tie this in with the drilling that we need to do to extend our resource and also exploration. Yeah. Structurally mineralised hits in both of these loads, so exploration success there, and of course we're getting continued success with our Augusta Deeps program on the W load, and also shooting through and seeing whether there's still anything left in the E load. All right. Now, this is a little long section of the W load in Augusta, and this is just showing just the grades and the distribution of grades. Now, what we talk about at a Costerfield is a gold equivalent, so that's looking at the basically 10 kilos of antimony metal in a tonne of rock, being worth 3 times what 1 gram of gold would be in a tonne of rock. So what we do is we just do a simple formula: 1% antimony times that by 3 and add that to the gold grade. So we come up with a gold equivalent, and so the red is the bonza grade. That's the good super grade stuff, which is over 20 grams a tonne equivalent, and this is also over a width of 1.8. So 1.8 is a critical mining width, if you like, for Costerfield, because that's obviously influences the way we're mining there, mechanised air leg. So you can see we've got quite a bit of success as we're mining down and going through our inferred zones, and that's got quite a bit of life left. The Augusta story. So we'll just keep going there. So this is one of the near mine. This is the end lobe we were talking about before, just to the north of Augusta, the main Augusta system. And actually, when I say just to the north, it runs sort of down to along the west of the system as well. But this is just some recent successes we've been having. The mining guys are actually developing on 3-level. They've come out on 3-level Augusta and mining in some inferred area in the end lode and having some success there, which is good. But very importantly, we've just put a hole through which is over 100 metres north, and obviously with the northerly plunge aspect of these systems being in the southern part of the Costerfield Dome is very exciting in that this has got a huge amount of potential around it, this particular hole. So, I mean, people sort of say, oh, well, what's that, 15 centimetres, 90 grams, 16.5%, seems really narrow. But we're able to mine these things in a narrow fashion because of the way we mine with mechanised air leg quite economically. So it is of huge interest to us, and that would be an economically mineable intersection, no doubt about it. They're the old workings there. So you can see the old timers are mining along these structures, and with various success. But then, of course, the base of the old timers workings is here. So we're really, it's amazing. You can just come in up to sort of 50, 80 years later, come underneath and get this stuff. I just think it's incredible. And again, this is the Allison prospect that we've just been doing some drilling on, and this is these numbers are out of the latest release we released to Toronto as well. A couple of weeks ago. And again, very, very nice hits. This is an interpreted fault. Now these systems, this is, as I say, an inferred position. This fault, and it's interesting hearing one of the guys talking before about supposed flat fault situations offsetting loads, and in actual fact, are they laminated torch systems following least paths of resistance? And I really think we've got a similar situation happening here. What we had was a historic, and through the really good work of Brian Cuffley, had a situation where that was interpreted as being a what they call a slide. That's the old term, a slide, or or a back fault or flat fault. And what the old timers did was work down to that fault. Couldn't really find where the ore was offsetting below that, so all activities were terminated. This shaft is 3 compartment shaft down to 130 metres, and then that was it. Just stopped. And there was further workings to the north with the new Allison and Bradleys, but really, I was amazed. Well, not amazed, but just thankfully came through with some success drilling underneath Brian's, historic work, and the research was done. And sure enough, here we've got onto what we think is a West Allison vein that was worked historically. Excuse me. And then again, followed. Obviously, we've done some follow-up drilling now, and we've got this is 50 metres to the south and down dip a little bit. Got a very nice hit there as well. And you can see this mineralisation is wider. May not quite have the gold grades, but definitely the antimony grades speak for itself. It's very, very nice. All right, so we'll just. This is one of Chris Davis's great creations. So this is trying to show the interaction of high grade as we're looking from south to north through E lode and through W lode in the Augusta deposit, the interaction of some cross faults which are northwest trending and they dip to the northwest, dip to the northeast, and the interaction between these faults and the high grade chute control of the ore body. So we're looking at areas like this where you've got these transverse faults almost bounding some of these high grade areas. And again, more transverse faults coming through and dominating in some ways the chute control of the deposit. And that's really what we're picking up this information that Mike Mong and Chris are gathering for us in the mine, and using this to the best of our ability when we're going and drilling the Allison and the end-lode prospects, and later on when we go to Costerfield Main. So, continue on there. So this is just a bit of a look at what we're mining and what we're drilling in Costerfield itself. It's fantastic little ore body. It repeats gold grades very well. Our nugget is like comparative to the rest of, say, the Bendigo and the Goldfields region, really low gold nugget, which we're happy to have. You can see these things are quite narrow. I mean, this. The high grade zone in this particular intercept here, you're looking at only sort of 20-30 centimetres wide, and then you might have a lower grade fault mush zone with disseminated arsenopyrite, stibnite, and sort of going off into the hanging wall and into the footwall, and very much the traditional laminated quartz style edges, if you like, of some of the highly mineralised structures, obviously providing that annealing effect and fluid over time, the growths of the laminated areas there, and often we see an increased visible gold association with those as well. And again, just noting there that the big core diameter again to gain the sample support, particularly if we want to, as a geologist, you always want to sample these things very qualitatively in as far as, okay, where's my gold sitting? Is it there or is it here? We get quite a lot of free milling gold in the antimony or the stibnite package. However, at the moment we choose to sell that as a bulk con with the gold, and you can imagine the smelter is the only person who wins there. So what we're all about now is going forward is in exploration, trying to provide the mine with a bit of a metallurgical information about, okay, how much of that is free milling, and then sampling this as well. Now, of course, if you sample that little bit by itself, you hardly get enough sample mass once you do fire assay and antimony titration to actually get those results. So what we try and do is do HQ drilling to give us that sample support for that. Sorry, just a bit of digression there onto the core. And also just some photomicrographs there of the different sort of metallurgical and mineralogical relationships we've got there. So you can see the visible gold grains, and in the quartz matrix. Often you'll find that the high grade zones are in a milled quartz breccia, and that we've got visible gold both in the stibnite package, but also we've got the visible gold in the quartz rich parts as well, including the laminated quartz. This is underground, so looking south on W lode, we've got a nice package of basically massive stibnite with laminated quartz, and there would be visible gold in that as well. And you can see here the guys underground do a great job. They're putting the bedding relationships, again going back to those sections we looked at before, where you've got these parasitic anticlines, synclines on the Costerfield dome, on the west limb of the dome arrangement. We're all about looking at the relationships between the disc concordant bedding and the development of the lodes. And you can see there's an E lode, that's a north drive. You can see how there's a little bit of disconcordance between the bedding. That's very significant for us in terms of possible dilational positions, and also the higher the grades, both in terms of antimony and gold. And so that's, yeah, it's just something that's done, and all this, of course, all this data again captured, digitised, and put into block models and schedules. Yeah. So, and that's about it. It's a bit sort of short and sweet, but that's just a historic picture looking from Costerfield main shaft, which is now gone, but looking back towards Minerva and Bombay shafts, which we'll be drilling under next. So that'll be really exciting. Yeah. Thank you.